Hello Honor Chem students, a video here to talk about pH and how to calculate pH and things associated with pH. You guys watched that video that gave you a perspective of what it really means to be log base 10. It's not linear like so much of in our life is. As this goes up, the same kind of increments. pH is different. It's more of an exponential type growth, and I know that you've experienced some of this stuff in your math classes as well, but I just want to talk about like some data here. Like if we were looking in the macroscopic scale, a table below gives the distance for various planets and the stars near our sun. So this would be the distance in millions of kilometers between Mercury, Earth, Jupiter, Pluto, and our sun. And they went ahead and they graphed it here as well too, where you can see that Pluto is really far out, quite a bit compared to Mercury, Earth, and Jupiter. And then if we're trying to plot something like Proxima Centauri or the Andromeda galaxies, you know, we would have to have a really long number line to do that. So some of the things that we do then to be able to deal with these order of magnitudes is that we deal with things in base 10 power, which you guys know of as log. Okay, well, pH is going to be one of those instances where we're going to be working with a logarithmic scale. pH actually stands for this word ponderous hydrogeny. I think that's how you say it, which basically stands for hydrogen weight, or sometimes you'll hear people talk about the power of hydrogen. pH is a measure of the hydrogen ion concentration that's in a solution, and this is how we define pH. This would be a good thing for you guys to know. pH is equal to the negative log of the hydrogen ion concentration. pH is on a log scale, and log means base 10. So if we have a pH of 3, it is 10 times more hydrogen than a pH of 2. If we have a pH of 4, it means there's 100 times more hydrogen than a pH of 2. So here also, what I like about this table is that there's also a hydroxide component to it. So if we have a large amount of hydrogen, we have less of the hydroxide, and they are related. Okay, so the pH scale, which would be really a pain in the, pain, just basically to have to write these really small concentrations all of the time. So we use what we call a pH scale. And a pH scale measures, I'm going to get out of the way here for a minute, it measures the amount of acid or the hydrogen ion concentration. So things with a low pH value have higher concentrations of hydrogen than things with a high pH value have lower concentration of hydrogen ions. And this is what we determine as either being acidic, neutral, or basic. So anything with a pH of 7 or lower, we would say is acidic. And anything with a pH of greater than 7, we say is basic. And when your pH is exactly at 7, that's when we say that the solution would be neutral. Okay, so you guys have seen pictures like this, right, where there's actually, like, we can measure things with what we call pH paper, and depending on the color, we could determine the pH. So things like stomach acid, apple juice, black coffee, those are more on the acidic range, whereas hand soap, household ammonia, drain cleaners, those are more in the basic range of solutions. And all of our solutions in everyday life have a certain pH. So it's something that's very common that people will test to test the pH of a solution. There are some pH equations that are important to know. pH is equal to the negative log of the hydrogen ion concentration. We can also then measure something called the pOH, which is also the negative log of the hydroxide ion concentration. So it's kind of on the other side of that. And if we take the pH and the pOH together and we add them, we would end up with a value of 14. So I want to do this problem right here. It says find the pH and the pOH of a solution containing the hydrogen ion concentration of 5.2 times 10 to the negative 3 molar. And remember, this could also be H3O plus. Remember that H3O plus and H plus mean the same thing. Okay, so to solve a problem like this, we're going to use these equations right here to get us the pH, and then we're going to use this equation here to get us the pOH. Okay, so since I know the hydrogen ion concentrations, and I strongly suggest you guys do this because you will have more success and less chance of making an error if you show the equation and then you show the substitution when you're doing your work. So we know that pH is equal to the negative log of the hydrogen ion concentration. So what I'm going to do is I'm going to take the negative log of 5.2 times 10 to the negative 3. And there's a negative there. And I'm going to punch that into my calculator. And to punch that into my calculator, I am actually this kind of old-fashioned calculator that I have, and hopefully you guys know how to use your calculator. If you don't, you can always reach out to me and we can do a Google Meet, and I'd be happy to help you with that. But here I'm going to hit negative log, and then it's 5.2, and I'm using the second double E, so I'm using that double E button, negative 3, and I hit enter, and I get 2.28. So that would be my answer for the pH, is 2.28. Then to find the pOH, I'm going to just use this equation up there. I know that pH plus pOH equals 14. So I'm going to plug in 2.28 here. I'm going to solve for my pOH. And this is 14. So to solve for this, pOH would basically be 14 minus 2.28. And when I did that work, I came up with 11.72. So using the pH and pOH equations is not really all that difficult, okay? Inverse log. Sometimes, let me get out of the way here. Sometimes it's useful to find the hydrogen ion concentration from the pH value. And so to do this, we must use what we call the inverse log. The inverse log, if you look on your calculator button, and when you see your log button, the inverse is probably the second function to that. So when I'm looking at my calculator here, I see the log button, and then above that I see 10 to the x. That is the inverse, which you can see right here. Let me get this moved up a little bit. If you can see right here, that's what this is here. This would be 10 to, and then in this case, the x would be my pH value, okay? So let's try a problem like this. It says, what is the hydrogen ion concentration of a solution that has a pH of 4.3? So to solve this, what you're going to want to do is you're going to want to, again, show the equation and then show the substitution. So we know that the hydrogen ion concentration is equal to 10 to the negative pH value. So my hydrogen ion concentration is literally going to be 10 to the negative 4.3. Now, you can't just leave it at that. I want it simplified. And so to do that, I'm going to grab my calculator here, and I'm going to go on my calculator. I'm going to calculate this, which I didn't do beforehand, so let's just see. I'm going to go negative 4.3, and then I'm hitting that second log function, that inverse log function. So actually I hit inverse log negative 4.3, and I end up with 1, 2, 3, 4, 5. 5.0. So it's going to be, that's a 5.0 times 10 to the negative 1, 2, 3, 4, 5 times 10 to the negative 5. And the unit for this would be molar, okay? And that's how you do those calculations. There'll be more practice on the next video as well too, but you should get used to knowing how to do this. Again, if you're having any issues, please reach out and I'm here to help you.